Hi, this is Miss Logan. Today I will be talking about projectile motion. This is part 1 of 2 videos. Okay, so a projectile is any object that is projected by some means. So that means it's moving in both the x direction and the y direction. It's going to continue to move due to its own mass and will only stop if something else stops it. So this could be the ground, it could be a wall, something has to stop it. So projectiles are moving in 2 directions. They are moving in the horizontal x and the y. We need to always have 2 components to our problem, one in the x and one in the y. So the horizontal x component, my velocity will never change. The initial horizontal velocity is going to equal the final horizontal velocity. But why is this happening? Gravity is not affecting the horizontal or increasing or decreasing it. So my VF will always equal my VI. In the vertical component, our changes are due to gravity only. Our initial velocity will be 0, and our acceleration will always be negative 9.8, just like the vertical problems we've always been doing. For horizontally launched projectiles, we are going to have some initial velocity and final velocity in the x, but they are always constant. So if it starts out at 3 meters per second, our final will be 3 meters per second. However, in the y, our initial velocity will always be 0 meters per second. We will also have our acceleration equal to negative 9.8 meters per second. So to solve one of these problems, we need to follow these steps every single time. The first thing we will do is draw a diagram. So if a ball is being launched off a cliff, we need to show that projectile, then show what's going on in the x and the y direction. You'll see in our examples that we'll also write down what we know. Then we need to write down our known and our unknowns in our x and our y directions. I like to use this table every time to solve it. First, I'll look in the x, what do I know? And then what do I know in my y? It is extremely important that we separate these two. Then you'll determine which equation to solve and solve the problem. Okay, let's do our first practice problem. We are only going to set it up. We're only going to figure out our answers in the x and the y direction. So you were taking a running leap off a high dive platform. You were running at 8 meters per second and you hit the water 2.6 seconds later. So I have my high dive here. I am walking off and going down. Okay? So I have a starting velocity of 2.8 meters per second and my time is 2.6 seconds. Sounds good. I am looking for how high this distance is, and I'm also looking for my horizontal distance. Okay, let's set this up. So we know in the x, my initial and my final are both equal to 2.8. Nothing else is affecting it. We also know my time is 2.6 seconds. This is both for the x and y. I'm looking for my distance. In my vertical, I know my initial velocity is 0, my acceleration is 9.8, and my time is also 2.6. I'm also looking for my distance. So right here we solved about half of the problem. Our next step would be choosing the equations and solving for our 2 variables. All right, so let's solve this problem together. The setup is always the same for my horizontally launched objects. So a pool ball leaves a 6-meter high table with an initial horizontal velocity of 2.4 meters per second. So predict the time required for the pool ball to fall to the ground and the horizontal distance between the table's edge and the ball landing. So we're looking for this horizontal distance right here. So I drew it out, read the problem, let's write down what we know. So in the horizontal, my velocity initial and velocity final are always the same. And I know I'm looking for the time and delta x. In the y, I always start out knowing that my velocity initial is 0 because it's horizontally launched. My acceleration is negative 9.8 meters per second squared. I also know that my delta x is 0.6, and I'm looking for my time. Alright, so at this point I have all my knowns in my x and my unknowns in my x and my knowns and unknowns in my y. Because I know more in my y, we need to get started with this first. So I am missing a few different things. I do not have VF, so I need to use this equation to solve for time. So remember, we're still solving these at this point the same exact way we did before. So I can get rid of VIT because it's 0. So now I have delta x equals 1/2 AT squared. From here I need to rearrange my equation. So 2 delta x over A square root. I did skip some steps in there just to save a little bit of time, but I rearranged the equation. From here I can just plug in my knowns and unknowns. So I have 2 times negative 0.6. Why is it negative? It's going down, over negative 9.8. So for my answer, I'm going to get 0.35 seconds. So at this point I know my time, and as a reminder, my time is always the same in the x and the y. So I can actually just write this in here. Now I can solve for my horizontal distance. Okay, so I do not have acceleration, so I'll be using this equation. Now you'll notice in the x direction, because I never have any acceleration, I'm always using this equation. Alright, so let's plug my numbers in from before. I have 2.4 plus 2.4 over 2 times my time of 0.35. Now, let's just talk about something real quick. If I have the same up here, I actually have 2 of 2.4 over 2. So that's just something you'll notice as we go through these problems that'll make it a little bit easier. So for my final answer, I will get delta x equals 0.84 meters.